And we're back. So happy morning, afternoon, evening, or night, depending when you're watching this. So we're going to tackle rearranging formulas. So you'll see here on the screen, there are numerous formulas here that we're going to be rearranging. Notice it says isolate. So isolating means the same thing as rearranging. So for instance, the first one says isolate for R or rearrange for R. So we want to be able to do all of this. Now, before we get into all of these examples, there is a few things that you should know. And I want to relate it back to basically when you are rearranging or isolating or solving for an unknown, when there are just numbers and then there's only one unknown, unlike formulas. So let's do that first. So I want to take you through that, and then I'm going to come back to these examples and we're going to walk through every single example. So indeed, it's going to be a little bit lengthy in this video. Okay, so first thing is first. So one of the more common ones, okay, that I'm going to go through, okay, is this AX is equal to B, and let's assume that we want to be able to isolate, rearrange, or solve for X. Now, this seems like it's a formula. And for students, you know, you can relate this back, okay? What would you have done if you were just given this? So notice we're solving for X, but now we have a bunch of numbers, all right? And rearranging for a variable or an unknown when everything else is just a number is that much easier. So what I'm gonna do is I would encourage you, so I'm gonna put a link up above to a playlist that basically goes over the solving or rearranging for an unknown when everything else is just a number. So you have just one unknown. And you can watch that and make sure that you understand. So that playlist, it does have quite a few items there if you want to go back and refresh yourself. Now for this example, so notice what would happen is, and I'm working here on the right hand side, so what you would have done to solve this is you would have just divided by 2 on both sides to get rid of this, and you would get X is equal to, in this case we could actually solve this and this equals to 2. When you have formulas, the exact same process occurs. So for instance, if I want to solve for this X and you have an A or a Y or a Z or any other variable or even numerous variables, well, you want to get rid of them, and to get rid of them you have to divide by what you do not want on both sides. And in this case the A's would cancel and you would get X is equal to B over A. Now because it's a formula, notice I can't actually solve because I do not know what B over A is unless somebody gives that to me. And that is kind of the substitution, okay, that will be done. And I'll run a video for substitution as well. I'll put a link up above once it's done. All right, so you'll see that. So that is the first step, okay? So it is identical to the right-hand side, and I'm going to walk you through all of these kind of identities between formulas and actual numbers. So now the second one, what if instead we had something like this? So we have kind of almost like in fractional form, or sometimes, you know, you might see this and it might look like AX and then over, okay, B, which is equal to C. So both of these are identical. Now in the world of numbers, then what this would have been is, for instance, I can relate this back to simply saying something like this, or, you know, something like this. And now that C, okay, let me get rid of that C and actually put a number in there so that you can see that it's all numbers. So the question is, now what would I do if I wanted to solve for this X right here or this X right here if I had those numbers? And you may recall, again, if you know how to solve for an unknown, that what you would have done is you would have basically gotten rid of, okay, so the 3 in the denominator and then the 2, and you would have done that exactly to the opposite side as well. So it's kind of like cross multiplication. This cancels out, and then I have X is equal to, And now again, because I have numbers on the right hand side, I can actually compute them. So I have 18 and then it's multiplied by 3 over 2. So notice that the 2 actually goes into 18 9 times. So that's reducing, and 9 times 3 is 27. So I have an answer. I've solved for the x. On the left hand side, when you have formulas, you will do exactly the same thing. So what I'm going to do here is I'm going to take this, and let's say if I am solving for this x, so what I'm going to do is I'm going to say, well, I don't want a b and I do not want the a, so that this cancels the a and then the b cancels. And again, on the right hand side, so what I would do is exactly the same thing, b over a. Now unfortunately, because I do not know what a, b, and c are, then what I have to do is I can leave it like this. Or okay, what would happen is you have c times b, so people would typically write it like this. All right, and then it would have been a, because don't forget you have a 1 there, so 1 times a. And that's the best you can do. But these two, the right hand side that you see there and then the left hand side in the formula form, they follow the same process. That's why it's so important and crucial to really comprehend and understand solving for an unknown with numbers, so that you actually know what you have to do to get rid of something that you do not want. Another common thing in these solving things, okay, so here is another one. So, and I'm going to put this in. So let's say I have ax plus by is equal to c. And again, what I'm going to do is I'm going to be solving for this x. Now, you could solve for any variable that you like, okay? The process will be the same. So I'm just picking here on x. But as you can see, we have really no x's in these formulas that we're going to be rearranging, okay, and when I come back to them. So now, how does this relate? Because I want to be solving for x. So this basically relates back to something like this. So let's say I have 2x plus. Now notice the b and the y, they could have been just some numbers. So I'm going to put them, now if they were just some numbers, you could multiply them, and let's say I'm going to make this up. Okay, and let's make it, okay, because I've no, so it could be negatives. Let's say I had something like this, okay, and it's equal to 3. So what we have is here, this is your ax. So here, this is kind of like your ax. This is your by. So this is another term, except again, remember, now we know the numbers. So now the question is, how would you solve for x? Well, solving for x or isolating for it, you would have to actually, okay, move everything to one side and then keep your x's on the other side. So what I'm going to do here is I'm going to shift this over. Now, what happens in this situation when you move a term? The sign changes, right? Because really what you're doing is you're going to be getting rid of that -4 from both sides. So what you would have had is you would have had this 2x left there, and you would have had 3. The sign changes to a 4, and now great. So what I have is 3 plus 4, which is 7. So that's what I would have done because I know those numbers. And now, okay, this is deja vu. I would get rid of the 2 by dividing by 2 on both sides, and I have x is equal to 7 over 2. Now you can change it to decimal if you like, or whatever your teachers want you to do. But that's what you would have done if it was numbers. Now, how is this any different from formulas? It isn't. When you have a term, so for instance, in our case, now we are stuck with this term right here, which does not have an x. When you have something like that and you do not want it because you're isolating for x, then what you must do is you must shift it over to the other side, just as we did with the -4. So now if I do that, so what I'm going to have is ax now is equal to c minus by. Notice the sign changed. But now I can't really say what c minus by is because I don't know those numbers. So I just leave them because they're just a formula. And now again, the last step would be just like it was right here when we were dividing by 2. So notice we had a 2 here, so we divided by 2 to get rid of it, to isolate for x. So that's what I have to do here. I have to get rid of this a, okay, and I have to do that to both sides. So I'm going to be dividing everything on the right-hand side by a. So this is x is equal to c minus by all over a. And that's as good as it gets because it is a formula and I do not know what those variables are in terms of numbers. If I knew them, I could have given you an answer like we had here, but I do not. So that's another thing. So moving terms, okay, is the same. What else do we run into, okay, within these formulas? So what we have is, so another item which is very common, okay, it's something like this that you may run into eventually. So now I have, let's say, x's like this, right? So ax plus bx is equal to c. And notice if I'm solving for x, so if I have this, so I have x here and x here. Now I don't know what the a and the b is. Now, if these were numbers, so if I go back here and let's say I had something like this, 2x plus 3x, okay, is equal to 10, for example. What you would have done in this situation on the right-hand side, you would have said, well, these are just like terms, right? So this, okay, is a like term with this, and all I'm going to do is I'm going to say 2 plus 3, and I'm going to get 5x is equal to 10. But what you really were doing is you were doing this. You were saying 2 plus 3, okay, and then your x is there. That's what you had. So the 2 plus the 3, you could add them together because they're numbers. And that way, when the 5x came along, now you can say, okay, great, I can now divide by 5. And x, so that will cancel, is going to be equal to 2. That's the beauty when everything else is a number and you just have one unknown. So now what I want to show you is, okay, we have to look at what happened here, okay, where we basically took the 2 and the 3 and we added them together. So what we do is we call it, we factor out the x. So here we have an x and here we have an x. And you can imagine exactly the same thing, that the 2 that we had and the 3, that's your a and the b. So what we do is we have a plus the b, okay, and then the x is factored outside. Now, I cannot add the a and the b because I don't know what the numbers are. So the a and the b just stays in brackets. And now I have this is equal to c. And notice that a plus b was equal to 5, okay, in this step right there, because I could add them. But then what did you do to get rid of the 5? You divided by 5 because you were solving for x. So here we do exactly the same thing, except it looks very awkward because we are dividing, okay, by this entire bracket. Right? And the reason is because we want to get rid of this junk so that it cancels out. And of course, I have to do that also on the right-hand side. So now I have x is equal to c divided by a plus b. Now you can keep the a plus b in the brackets, but it's unnecessary. So that's another thing. This is called factoring out, okay, whatever variable that you want to be able to isolate for. So you're going to run into this at times. All right? So that's another thing which I hope that you understood in this explanation. And now here's kind of a final item before I start tackling all of those different formulas that we had. So what if, now again, now I have brackets here. So I have b, x, let's say, plus c is equal to d. All right, so what if I had something like this? And again, let me relate it back to numbers, okay, so that you can see what I'm talking about. So let's say we had, so do we have something of this nature? All right, so they look identical, except I took the a, the b, the c, and the d, and I put numbers for them. And what my interest is, I want to be able to solve for this x. Now, if you were solving for this x, okay, let's again shift over to the right hand side where it's just numbers. What would we do? Well, you can do two things. okay, in here. You can do A, I can bring this inside of the bracket like this, all right? I can do that, okay? So that's something that we could have done. Or, because it's outside of the bracket, what we could also do is we can say, let's divide everything by 2, okay? And then we can get started, right? So, and we would do that and we would go ahead and proceed, right? So those are the two things that you can run into. It doesn't really matter which one you do, all right? So let me, okay, and I do it, it depends, whatever it is convenient. So here with the numbers, I'm gonna bring this inside. So this is gonna be 4x plus 8 is equal to 11. And now from here, in terms of solving, well, it's exactly the same. I do not want the 8. I'm going to bring it over to the other side. So I'm going to have 11 minus 8. So that's going to be 3. And then I have the 4. I'm going to divide by 4 on both sides. Okay, and this is x is equal to basically 3/4. So with numbers, great. It's, simpler. Now, what about the left-hand side? Right? So how can we kind of mimic this without? So again, we can do one of two things. We can either bring this a inside of the bracket, okay? That's one thing. Or we can say, let's divide by a on both sides so that we can get rid of the a in front of that bracket because it's just a factor. So that is up to you, right? Whichever way you go. All right, so that is something that you can do. So I'm going to mimic what we did on the right-hand side. Not that it's always the best idea. That is actually just experience and being able to see and do enough of these. For the moment when you're starting, just pick one and then go with it. All right, so I'm going to distribute this out. So I'm going to get a times b x plus a times c is equal to d. Notice, because I don't know those variables, that's the best that I can do. And now, okay, so just as we had in here, we move the 8 over on the other side. Because I'm solving for x, I'm going to shift this AC on the other side. So this is going to shift over. So I'm going to have ABX is equal to D minus AC. All right, so because I shifted it over, the actual sign has changed. And now finally, to finish this, I want to get rid of the a and the b. So I have to divide both sides by ab so that this cancels. And I have x is equal to d minus ac all over a over b. Right? And that's your formula. Now, if you put at the bottom AB or BA, the multiplication doesn't matter. Typically in math, we put it in kind of alphabetical order, if whenever possible. So that's what we like to do. Okay? So these were things that I wanted you to keep in mind. And you can go over these. They're not easy to transition from numbers to formulas, but you gotta be able to grind them out. All right? So now let's take a look at the actual formulas and start solving them. So I'm gonna go back here. Okay, so let's grab several of them. Okay, so I'm gonna grab as many here as I can so that I can I'll put them there at the bottom. Okay, so this is all of these questions. Okay, I wanna be able to do and solve them. Okay, so let's paste it back and let's get started. All right, so here is question number 1. So we want to take this, I want to copy it, okay, and I'm going to start solving them out. So here is our first one. Now, you may not know what this P, this V, this N, this R, this T actually means, especially in the beginning. Eventually, you may know what the formulas are coming from. All right, so this is kind of the ideal gas law. It doesn't really matter if you're just interested in solving for a variable. So we're interested in solving for R, right? We want R only. So now we got to think back, all right, so how do I solve for R? Okay, because that's the only thing you want. So I'm going to think back of what I know with numbers. Well, If I only want r, I definitely do not want n, and I do not want t. So I'm going to divide by n and divide by t so they cancel. Okay, so they cancel out. And remember, I have to do that on both sides. So notice, so this is r, this is going to be p over v, and then nt. And you're done. That is it, because you do not know what those variables are. Okay, but you've isolated for what you wanted. Now, of course, some people will like to have the unknown on the left-hand side, so you can do a mirror image. Okay, it means exactly the same thing if you read it from the right or from the left. So that was example, the first one. Okay, let's take a look at another one. So this one is a little bit harder, more challenging. So what happens here? So let me copy this. Let me bring it down here, and let's take a look. So now I want to be able to isolate for ti. Well, ti is here at the bottom. It's in the denominator. Now you will remember, if you studied the solving for an unknown, when your unknown is in the denominator, you want to bring it back into the numerator, to the top. You don't want to have denominators, okay, with your unknown that you're solving for. So now we're a little bit stuck. We have this thing, so let me copy it. I'm going to paste it in here so we can work with it. So I do not want this whole thing in the denominator. So what I'm going to do is I'm going to multiply both sides by this t subscript f ti. And by the way, this subscript f and subscript I, they're part of your unknown. Okay, it's not d times f or d times I. Okay, when there are subscripts, they're just, okay, one unknown. So now this cancels, so that is gone. Okay, but of course I have to do that on the opposite side as well. So I'm going to have tf minus ti here. So now what? Well, now I have simplified this, so this kind of looks like this. So tf minus ti. Now the v can go in the back or it can go in the front. It does not matter, because again, it's multiplication. So that's up to you. All right, so how you put it, okay, so you might see it either or. And then we have df, okay, minus di on the right hand side. And now what? Right? So now again, don't forget, what are we after? We're after this ti. That's the only thing we want. We don't want anything else. So now again, the question is, okay, I have this v. All right, so I have this v in here. And what can I do? Okay, because I don't want to have this v. So we said we could bring this into the brackets. That's one thing that we can do, right? We can do that. Or, okay, we can divide by v. Okay, so we can divide this by v. So we can do that. Okay, and we would have to do that to both sides. So those are the two steps that we could do at this moment. All right, so let's bring it inside of the brackets. All right, so I'm going to stick with that because we talked about this. So what would have happened? What would have happened is we would have this again. So this is v multiplied now by this tf minus, all right, v, okay, ti is equal to df minus di. I have no more brackets. Again, I am only after this. That's what I am after. That's what I want. So what that means is I do not want to have this. So I'm going to move this term over on the other side. Okay, so I'm going to shift that over. So that's going to shift over for me. So what I'm going to get is I'm going to have negative v ti is equal to df minus di. And then with that shifted, it's going to be minus v tf. Notice the sign has changed. Okay, so that's what I would have. Now finally, okay, because I am after this ti, so what I need to do is I need to divide both sides by negative v. So the negatives cancel, and so that the v cancels, and I have to do that to both sides. So this would be negative v. Okay, so this negative cancels, the v cancels, and voila, you have your ti. Now, the interesting thing is, okay, so your answer is df minus di, okay, minus v tf all over negative v. The one frustration you will find in the beginning that these formulas may look different. So there's nothing wrong with this, okay? This is perfectly fine. You've solved for your unknown. But sometimes, for instance, what you might see is this negative, all right? People may not like to have that negative. So what they will do is, because really it means -1, right? So that's what this means. So here what you have is, okay, it's kind of saying like I have a -1. So I am dividing by -1. And sometimes what people will do is they'll bring that up, that -1, and then they'll divide each term. So this, and this, okay, by -1. Here is example number 3. So let me take this one, let me bring it down. So I'm going to bring it here, paste it. All right, now I want to be able to isolate for t. So this one is going to be a little bit simpler. Okay, so what happens here? So my t is right there. So now what do? Well, again, we could bring this inside. Now what I'm going to do is, because we kept bringing it inside, what I'm going to do now is, instead, I'm going to divide both sides by p to show you, that this also works. Okay, so now I will have s over p is equal to 1 plus rt. Again, I am solving for this t. So what I'm going to do is I have to now bring out or get rid of, okay, so this is going to go over on the other side. So now this is going to shift over. So this is going to be s over p, notice -1 is equal to rt, because I shifted that over. And now finally, what do I do next? Because I want only t. So now you're going to have to divide both sides by r to get rid of this r right there. That's what you would have. All right, okay, and this would have been your final answer, meaning t is equal to s over p minus 1 divided by r. That would have been your final answer here. So there are different formulas that you're going to have to be able to tackle. All right, let's continue. And you can rewatch this, rewind them, try them on your own. Okay, so here is another one. So here is another formula. Let me take this, copy it properly. Let me bring it down. So I'm going to paste this along. And now I want to be able to isolate for PS, or PS is right here. Okay, so now what happens? Okay, so this one, that means I'm going to shift this over to the left-hand side. So I'm going to have PA. Now, this is going to be minus 3 over 5 PD is equal to 2 over 5 PS. I'm solving for this PS right there. So now I do not want to have the 2 over 5, right? So how do I get rid of that? To get rid of the 2 over 5, I have to multiply both sides by 5 over 2. So that this 5 cancels with the 5 and the 2 cancels with the 2. So again, I have to now multiply this entire side here by 5 over 2. Okay, so I have to multiply that. Now because it's a formula, so what we will end up with is this is going to be 5 over 2, okay, multiplied PA minus 3 over 5 PD is equal to PS. And that's it. And you have rearranged or isolated for what you wanted. Again, so these steps keep repeating. They're the same, but you have to be able to kind of go through and understand, what do I need to do? So I'm trying to just give you a lot of examples so that you can see, okay, on various types. So next example. So now we've walked through quite a few of them. So here is another one. So let me copy this. I'm going to bring it down. So here is another example that we have. So now we want to be able to isolate for t. Well, t is here at the bottom. All right. So as we said, we do not want to have the variable we're solving for in the denominator. So the first thing that I will actually do is I am going to take this. So I'm going to take this. Is not going to be a very hard question for us. So I am going to multiply by t on both sides. Again, why? Because I want to get rid of the t. It's in the denominator, so I'm going to multiply it through. So now what I have is I have my, so this is rd times t. Again, the order doesn't matter. And here I'm only going to have now v times r df. The subscript df just stays there. So now again, don't forget, I'm solving for this. So my final step would now be I have to divide by rd on both sides to solve for my t. So this is v times r df divided by rd. Okay, and you're done on that one. A little bit simpler there. All right, let's take a look. Let's continue. Try to see what else that we have. So our next one, so here this one looks like it's going to be a complicated one, or at least it seems like it. Okay, let's try it. So now we have next. All right, so this is whatever g is, probably a grade, is equal to probably the weight of the grade of your first one, maybe it was a test or something, plus so on. We want to be able to isolate this for, okay, W2 for this. We're stuck. We have it in the numerator and denominator. Again, in these cases, the first thing that we want to do is we want to be able to clear out the denominators. Okay, so when you have that, so we do not want, so I'm going to multiply this by W1 plus W2 to get rid of that entire denominator, and of course I have to do that to the other side as well. All right, so this will be gone, and now all I have, so I have W1 plus W2 multiplied by G is equal to, and now W1 G1 plus W2 G2. All right, so this is what I have now. Now, my problem is that I have W2 here and W2 here. I have to put them on the same side. It's like you were solving for x and you had x on the left and x on the right. You want to be able to bring them over and bring everything else over to the opposite side. So in this case, I am forced that I have to bring this inside of the bracket, okay, to get rid of the bracket. So I'm going to have, okay, so this is W1 times G plus W2 times G equals to W1 G1 plus W2 G2. Again, so here's my W2 and W2. What do I do now? I will bring, so this and this term to the same side. Right, so now let's bring them all over to that one side there. Okay, so we will have, let me just switch color here for just a second. So I will have, so W2G minus W2G2. So that's these two guys. And then W1G1 minus W1G. All right, so that's what I would have on the right hand side. Now, since I am trying to solve this for W2, so what I'm gonna do is, and I'm gonna be factoring Okay, so this W2 out. Okay, and we did that previously. All right, so you've seen that before, so you can kind of go back in the video if you like. So in order to take this out, so I'm going to take W2 out, and I'm going to have G minus G2. So notice I have taken that out. Now I can do the same thing on the right hand side with the W1. It's unnecessary really because we're solving for W2, so I'm just going to leave it. So we have this right here. All right, so that is that. And now dividing both sides. So I'm going to just divide both sides by G minus G2. All right, so that's what we will have there. This will cancel, and there you have it. W2 is equal to, now I can kind of copy this down. I'm going to cheat so I don't have to rewrite this again. So this is what I'll have. All right, and that would be it. All right, so for this one. Okay, so let's try another one coming up. Let's tackle the last one. Okay, so this will be our final one. As I said, this was a very long video. If you stuck all the way through it, okay, I hope you hit a thumbs up if you actually found it useful. Okay, the content is tough. So here is my last one. So I'm going to copy this. Okay, and then here, let's try to isolate, and then we'll end the video there. So let's paste it back in, and we are isolating for X. Here, notice X, X, and X. So we have it in 3 different places. Okay, let's get started. So first things first. Okay, well, luckily there's no denominators, but we do have brackets. So I'm going to get rid of these brackets here. I'm going to just shift this inside. So I'm going to get 2x plus b times x minus, okay, so the number I'll put in front, so 2by. So notice I've expanded the b into the bracket, okay, equals negative x plus y. Now my goal is I want to collect all the terms with the x. So those are these guys. So I'm going to bring them all to one side. All the other terms, so this term right here, are going to go on its separate side. So that means I have 2x plus bx. The negative x is going to now become positive x. And now I'm going to get y plus 2by because I moved this over to this side. So far, I hope you're with me. Now, again, I run into the same problem that I have this x. I have it in 3 different terms. So what I have to do now is I have to factor it out or collect like terms. Now, luckily, notice I have 2x and an x here. So you should know that 2x plus x is 3x. Okay, now the b will just stay the same. So I have this right there. So that was 2x plus the x. Those are just like terms. And now I'm going to remove the x. So that's going to leave me 3 plus b, okay, and then the x. Notice the 3 plus the b, that stays there. And now for my final step, you should now, because you've seen it a few times, you should know that I'm going to be dividing both sides. 3 plus b, so that I cancel this off, and then I get x, and here is our answer. Okay, so that's what this would be. And that completes the video. That's a very long one. I'm sorry. I wanted to give as many examples as I possibly can. All right, okay? Stay as positive as you can with these. Try to practice them, okay? And we'll see you in a future video. Bye, everybody.